Welcome to ABB Metals Tech Talks. Please note that you will be muted for the duration of this webinar. We will have a 30-minute presentation followed by a 10-minute question and answer session. You may submit your questions at any time via the chat window on your right. I would now like to introduce our first speaker for today, Mr. Joakim Andersson.
Good morning, everyone, ladies and gentlemen. My name is Joakim Andersson. I've been working as a metallurgist, and now my position is as a sales manager for North America region. I previously have experience as a process manager for Outokumpu Avesta in Sweden, and also other various technical roles in the process. More and more steel makers are shifting from blast furnace to electric arc furnace due to environmental reasons, cost reasons, flexibility of the production routes. It is estimated by 2040 that electric arc furnace has a 30% market share of the steel production. We from ABB are offering a solution for the electric arc furnace, and this is what we call the ArcSave, the electromagnetic stirrer for the electric arc furnace. This will give an increased efficiency, decreased energy consumption, increased yield, make it easier to operate the furnace with a higher flexibility. So why do we want to stir the electric arc furnace liquid metal? We know, for example, that the process in the electric arc furnace is far from equilibrium, both in temperature and in chemistry. So when we are stirring the liquid metal, we will have a more homogeneous bath. We will avoid the hot and cold spots in the liquid metal. We will have a faster scrap melting, especially true for big sizes of scrap. We will have a better ferrochromium melting and dissolution. We will then also avoid the furnace bottom skull formation. We will also have a much faster decarburization with a higher oxygen yield when we are blowing in the oxygen. This will fit the hot metal charging and pig iron charging. And also we will have a better temperature prediction, which is a much better endpoint prediction. The outcome of this is, of course, shorter power on time, increased productivity, reduced energy and consumable materials like electrode consumption, slag formers, alloy additions, and so forth. This will give a total improved cost efficiency of the electric arc furnace. We will also have smoother tapping conditions regarding the temperature, the weight, and the chemical analysis, which will then give a better outcome for the next process step, whether it will be the ladle furnace, the VOD, or the AOD converter. So why are we choosing then the ArcSave? ABB Metallurgy has a long experience of developing electromagnetic stirrers for different applications. It could be for the slab caster, it could be for the billet and blooms, and it could be for the aluminium furnace. We are the sole manufacturer of this technology. We are also creating a much stronger and controlled stirring profile, which we also have a design average melt volume flow velocity of around 0.2 to 0.4 meters per second. We are stirring the total entire melt, leaving no dead zones like competing technologies, for example, gas stirring, which has a very more localized stirring pattern. The stirring profile is fully adjustable, 0 to 100%, and has an automatic stirring profile, which can easily be adapted to the level 2 system of the customers. We can then also adapt it for different scrap sizes, scrap types, or alloy types, or different steel grades. We have a very low maintenance and long lifespan of the coil. To make an example of this, we have in Uddeholm in Sweden, which we have a stirrer coil which has been in operation for over 50 years. But in the unlikely event that you need to remove the stirrer due to a fault, it's fully possible to remove the EMS and continue to run the electric arc furnace independently of the coil. So, which available furnace can we use the ArcSave technology? We can use it as on the left side, you see, is a normal conventional bucket charging carbon steel furnace with an EBT tapping system. We can use it for the stainless special steel manufacturer, which normally use a spout tapping furnace with a normally a higher angle during tapping. We can also use it for our latest technology for the flat bath operation technology. For example, the Consteel furnace. In this case, we are shifting the stirrer 90 degrees perpendicular to the normal direction towards the Consteel charging area. So how does this ArcSave electromagnetic stirrer works? The stirrer is installed under the furnace on a cradle with a gap from the furnace bottom. The bottom of the furnace needs to be in austenitic stainless steel. For example, it could be 304L or 316L. When we are operating the stirrer, we are creating a traveling magnetic field which penetrates the bottom, the refractory, and generates a stirring force into the liquid metal. The auxiliary equipment is composed from the right, a cooling water station, a water skid, a transformer, a frequency converter, a fan which is blowing air between the stirrer and the furnace bottom. An optional is to put a junction box on the foundation for the electrical cables or a junction box on the cradle wagon. So, how has ArcSave helped the steel makers? Now we will look at some real cases and real results. We will start out with Steel Dynamics in Roanoke, United States. Here we installed the ArcSave in 2014 on a 90-ton electric arc furnace with an EBT tapping system. They were using 100% scrap with a daily production rate of 22 heats per day. The tap-to-tap time was 65 minutes and producing 600,000 tons of carbon steel annually. The customer objectives in this case was to increase the arc stability during the melting, improve the temperature and chemical homogeneity in the liquid bath. They wanted more consistent tapping condition to the next process step, lower tapping temperature, and reduced oxidant content. As you can see regarding the arc stability, you see a diagram which shows the current fluctuations during melting and also flat bath operation. So you can see clearly that the current fluctuations is much less with the ArcSave. And this is due that we are creating liquid metal much faster. We have a much faster melting rate when we are melting the scrap, and therefore we are creating a more stabilized arc pattern. On the right, you see a quote from the former melt shop manager Paul Schuler. ArcSave helps the melting process make liquid steel safer, quicker, and at a lower cost. And also here on the next slide, you see a summary of the benefits we got out from the performance test. Some is highlighted, for example, energy consumption was reduced by 5%. increased iron yield by 0.9%, which gave a cost savings of the operating cost of $4 to $5 per ton. And also an additional benefit was the productivity was increased by 6%. Other benefits which we saw from SDI Roanoke was smoother tapping conditions. We had a free EBT opening from around 70% up to 96% when we were using the stirring during the tapping. We also had less carryover slag to the ladle due that we could kill the vortex which forms during tapping of an EBT furnace at a later stage. Now, another problem, a serious problem for the EAF operator is the furnace so-called build-up or skull formation, which normally happens when melting special steel or big type of scrap sizes, and also other high melting alloys like ferrochromium and so forth. This creates numerous problems for the electric arc furnace operator. Reduced furnace volume, for example, lower tapping weight, yield loss, refractory problems, and also reduced productivity. One of our next reference which had this furnace bottom skull problem was Outokumpu Avesta in Sweden. Here we installed on a 90-ton spout furnace. In this case, they were using 90% scrap, producing 500,000 tons of special stainless per year. The average tap-to-tap time was 65 minutes in this case. For this case, the customer objective was, of course, to increase or dissolve the ferrochromium, which they use a lot in this furnace. And also, of course, solve the bottom skull problem they had. They also want to reduce the power off time and energy, and not the least, also achieve even analyzes temperature and weight to the next process step, which was in this case the AOD converter. They also used to have bottom gas stirring porous plugs, but this was routinely clogged around 100 to 150 heats, and therefore they couldn't use it due to the bottom skull problem and the very stiff slag. So one quote from one of the metallurgists at Outokumpu was, "We solved our bottom skull problem using the ArcSave. The result is smoother, more predictable electric arc furnace operation at a lower cost." Another also here is the table of the process improvement we got out from Avesta Outokumpu in Sweden. They had a reduced energy consumption of 3 to 4%, reduced power on time of 4 to 5%. And then for the next process step, they had a much smoother, predictable tapping condition, like the temperature heat ratio went from 30% to up to 100%. They had a tap weight heat ratio from around 60% to over 90%, and then a tapping temperature reduction of 20 to 30 degrees. Another customer which also used to have the skull formation was SIA in South Korea. Here we installed the ArcSave on a 70-ton electric arc furnace with the EBT tapping system. They had a tap-to-tap time of 65 to 75 minutes using 90% scrap. They produced annually 180,000 tons of tool steels and stainless steel. Here, the main objective was, of course, to reduce the bottom skull formation. Before discovering the ArcSave, CEA used to have 3 porous plugs in the bottom of the furnace. These plugs was routinely become clogged, as in the case in Avesta, by the bottom skull or the very stiff slag. For the CEA, the porous plugs led to more time-consuming and complicated maintenance while having a very short lifespan. But when they then installed the ArcSave, they managed to reduce the skull formation around almost 1 meter in this case. On the next slide, you have a summary of the results which we got out from CEA during the performance test. And just to highlight some of the result was, of course, the scrap handling cost reduction. This was reduced by 70 to 80%, due that in this case they could charge much bigger sizes for scrap, and they needed much less cutting of the scraps, which was a considerable saving for them. Also, of course, they could increase the scrap volume in the furnace and tap on a higher heat size, due that they could reduce the volume in the furnace. Other savings worth to mention was, of course, the hot gunning materials reduction was reduced by 40 to 50%. And this can explain that we had less superheating on the surface or on the meniscus, and therefore we had less slag attack in the slag line. Other saving was similar as in Avesta, for example, the electrical energy reduction, 3 to 4%, and power on time reduction, 4 to 5%. So, what is the typical benefits, what we can get out from the ArcSave? We have seen 3 cases, SDI, Avesta Outokumpu, and CEA in South Korea. Of course, we can get out and increase productivity by 5 to 7%. We can increase the yield of the steel by 1%. We can reduce the energy consumption by 3 to 5%. We can improve the overall process stability and repeatability. We can have a much better endpoint prediction to the next process step. This, of course, also gives a lower use of alloys. For example, we can have less alloys in the ladle furnace due to less oxygen in the slag and in the steel. We can have less slag formers, and also due to the arc stability, we can have less electrode consumption, and also other process additions. So here is our installed base. We have right now 158 references globally. This is composed of 149 first generation electromagnetic stirrers for the arc furnace. And then we had 9 new generation ArcSave. This ArcSave was developed more to the ultra high power furnace. The furnace today is much higher power, and therefore we need to have an electromagnetic stirrer with much higher power in this case. The new generation ArcSave that is worth that we can mention here, beside what we have mentioned for the case study, is, for example, Yongfeng Steel, Shandong in China, where we installed 2 ArcSave, which we are calling the Constirrer, for 2 Consteel furnaces. This was installed in 2019. We have an aluminous steel plant, which is a 450-ton Consteel furnace. This is probably the biggest furnace in the world right now. This will be installed during 2020. And then we have some tool steel, special steel manufacturing, like Berlo, Kaffenberg in Austria, Nippon Yakin in Japan. So now I'd like to hand over to my colleague Kevin Ball.
Good morning, everyone, and thank you, Joachim. Yes, my name is Kevin Ball, and I'm a commercial consultant working with ABB Metallurgy. I tend to focus on the customers who want to explore a new way of implementing an ArcSave project on their furnace. We call it ArcSave Solutions. I first worked with the metallurgy business on the STI Roanoke installation in the US that you've just heard about. There, we actually piloted a service concept with STI where all the facets of the project, including the necessary investment, were all taken care of by ABB. This innovation with STI has been both a commercial and a technical success for everyone involved, and we think this is now a perfect time to have this model refreshed and made more widely available to the market. More so than ever, as we all try to emerge from this terrible pandemic, capital investment programs are going to be severely constrained across all industries, not least the steel sector. I suspect that many strong commercial projects will simply not get done in the next few years. One common answer to a shortage of internal CAPEX is for operators to look for third-party financing. Most of these are vendor finance programs, and they simply result in another fixed cost obligation on your business. And once your finance or treasury departments look into the detail of these deals, they're often seen as simply debt and really sort of CAPEX in disguise. However, if the cash flow benefits of third-party financing are all you're looking for, then these lease-style hire purchase structures may be okay. But in my experience, it is very rarely the answer. So what we have developed here with ArcSave Solutions, we believe, is market leading and somewhat different. Here I represent what I call the usual planning cycle, where reducing operating costs are going to be a real focus for melt shops in the near term. But across your business, there are always going to be other investment priorities, and I'm sure you do not have project managers and engineering teams sat around looking for work. So resource constraints are usually just as much about limited human capital as it is financial. As a result, with limited investment, commercial CAPEX tends to be small or non-existent. So, in ArcSave Solutions, we deliver the opportunity through a long-term service partnership. ABB and investors will take all the performance risk of the technology for the duration of the agreement, and importantly, hold hands with you on your core business or production output. You only pay a fixed service tariff per ton of stirred production leaving your furnace. If there is no stirred production, there is obviously no service being delivered and hence no payment. We do need your involvement, and the main contributions from you as an operator of the melt shop are to share the obvious design information around your furnace, provide us with some utility connections of water and power at agreed locations, assist us with measuring your furnace performance both before to create a baseline and after the installation to verify the savings, and help us plan the final connections and tie-ins into one of your future planned shutdown period. And as Joachim said earlier, should the stirrer system be unavailable for any reason, steel production is not impacted. To make this service concept more tangible, here is an illustration for an imaginary 1 million ton a year. So Joachim has already shown you some of the commercial benefits from installing the system. So here I summarize that and imagine a project where around 50% of the benefit comes from those various cost-saving elements and 50% of the potential value as productivity value, where that can be monetized through increased sales. So we keep the service agreement very simple, such that The quality and the productivity benefits remain with you, the customer, and our agreement focuses on the cost-saving element. We always try to leave you with more than 50% of the savings during the service agreement term. I'd like to highlight two key elements of the agreement. Firstly, we fix the service tariff up front. There are no hidden indexation clauses. This flat tariff increases your share of the total savings in real terms as the agreement progresses. In my experience, there is nothing more certain to sour or end a long-term service relationship than annual escalation factors that inexorably increase your payments and can distort what starts off looking like a fair sharing of the value generated. Secondly, the term of the agreement is written in tons of stirred production, not a fixed period of years or time. Again, this ensures a sharing of the ups and downs of your production performance, and coupled with the known tariff, this makes this agreement a pure variable cost expense for your business. For those of you looking at this and thinking of how you present the internal business case, in this example, if you were to retain 60% of the cost savings and someone else makes the investment, and over 10 to 15 years, you are keeping over 85% of the investment value. Your shareholders, proving your EBITDA for the operation without having to invest the upfront cash. Finally, once an ArcSave solution agreement is in place, ideally as a frame agreement where you have multiple sites, we can then easily expand the collaboration to more than one site and integrate other technologies that could add further cost savings to each furnace. What I'd like to do now is hand you back to Karen, and she'll talk you through the final part of the webinar, the Q&A session.
Thank you, Kevin. Now, based on what we have presented so far, if you would like to know more about ArcSave as a traditional product, then you can write ArcSave in the chat window and we will contact you after the webinar. If you would like to know more about ArcSave as a long-term service agreement, then you can type service in the chat window and we will contact you about that personally after the call. So, in the meantime, let's start the Q&A session. We have our two speakers for today on the Q&A panel, as well as our senior metallurgist, Lidong Peng. So let's go to our first question. For Joachim, do you have any experience of working with this technology for DC furnaces?
Regarding DC furnace, we have no experience for that. Mostly our application is for the AC furnace. Of course, it could be developed, but it could be a little bit more complicated installation. That's my answer on that. Thanks.
Okay. Another question for you. What size of electric arc furnace is suitable for ArcSave?
Also, the sizes we have today is, we are going from 50 to 450 ton. Of course, we can make for all type of furnaces, whether it will be 10 ton up to 450 ton. But the sizes we have right now is from 50 to 450 ton. Thank you.
Okay. Let's see. Lidong, I have a question for you. Does ArcSave have any effect on steel quality?
Yes, this is Lidong, and for this question, the answer is yes. For arc furnace, normally we see melting unit, but for high quality steel production, it's also very important, such as phosphor removal, sulfur removal, nitrogen. Actually, we have looked at these results in our installation, which Joachim mentioned, SDI Steel Dynamics in Ronald. And we found, for example, the phosphor, after tapping in the ladle for sample, it was reduced about 8% less, about 10 ppm reduced. And also for nitrogen, of course, for nitrogen, some still may be very sensitive with nitrogen. Yeah? And nitrogen was reduced about 20%, almost 20 ppm. And also sulfur, 10 ppm. So for this, I think the quality to some extent improved if you produce quality steel. Yeah, thank you.
Thank you, Lidong. A couple of questions for you, Kevin. We'll start with the first one. Can any other technologies be incorporated in the long-term service agreement model? And if so, is it only available for ABB technologies?
Oh, that's a really good question, Karen. Yes, we found over the last few months, talking to colleagues in ABB, of course, there are other technologies ABB has which we can bring into the model around the arc furnace and the steel plant. Many of our customers will be aware of other products ABB makes, but also some other leading OEMs have been in touch, having heard about the ArcSave platform. We could join with them as well and bring them into the ArcSave solution. So that's something I'm actively exploring. And at the moment on the drawing board, talking to 2 or 3 OEMs, you could imagine a collaboration around leading technologies that might get you to an energy saving if you did a single large project, anywhere up to 20% on the furnace. So use the stirrer as that initial sort of 5% energy saving. We could then build a far more strategic project using other leading OEMs. So it's a great question. And for customers on the call, you may have other companies and other technology that you're looking at around your furnace, and we're very open to collaborating with other OEMs and other parts of ABB and finding the right project, building off the stirrer as the foundation.
Okay, and another question for you, Kevin, following on from that. If multiple technologies can be included in the service agreement, what potential savings can we expect?
Well, yeah, as I just mentioned then, I think if we focus on energy and we look at all the various best-in-class technologies around energy efficiency, heat recovery, variable speed drives. I mean, some customers still have fixed speed motors in their baghouse. There's big variable speed applications there to save energy. And I think you can easily see a 20% reduction in the power purchase to run an arc furnace if you put together 2 or 3 of the best technologies with the stirrer. So I think we'll start with the stirrer, and we'll get those projects underway, and then we'll see if we can build a bigger alliance of OEMs together with us.
Thanks, Kevin. I have a question for Joachim. Do you have any references relating to revamp projects for installing a stirrer on an existing electric arc furnace?
Yes, a good question. I mean, if we look at our reference base regarding ArcSave, 4 of our installation is from a revamp. So we have Avesta Outokumpu, which was certainly a revamp project. We have SDI, Steel Dynamics in Roanoke. We have POSCO Puyang, and we have CEA. So it's fully possible to do a sort of say brownfield revamp. Of course, what you need to think about is that you need probably a new lower shell or a stainless cutout in the bottom of the furnace.
Okay.
I think that's the answer.
Okay. I have another question for you, Joachim. Is it normal to stop using porous plugs or to remove them entirely after installing an electromagnetic stirrer like ArcSave?
Yes, as you see, the case study we had, for example, for Avesta Outokumpu, which used to have porous plugs, and CEA, they used to have porous plugs. So when we are installing the ArcSave, there is no need to have the porous plugs. Due that, as I said in the presentation, the stirring profile is much more powerful and controllable compared to porous plugs, which is more localized stir. Thank you.
Okay, I have a question for Anders, who's not shown on screen. Can you tell us something about what the typical payback is for an ArcSave?
Yes, thanks, Karen. What we usually have seen during the last couple of installations is that the payback is around 1 to 1.5 years for the equipment of the ArcSave and also the modification of the furnace. In general, we can say that the larger furnace, the shorter payback. And also, of course, if you have productivity gain, then this can shorten it even further. So when we say 1 to 1.5 years, it's without productivity gain. Thank you.
Thank you, Anders. A question for Lidong. Can you tell us something about advantages that there might be for ArcSave compared to purging plugs?
Yes, this is always the question asked by many potential customers. Yeah, for the gas stirring, I would say it's from the operation point, it's much more complex. Yeah, but the ArcSave is EMS is installed. There is no underneath the furnace. Yeah, as we saw from the Joachim's presentation. There is no physical contact between the mat and the EMS, but the porous plug, is installed and it's in the bottom refractory, so it could be a risk for this breakthrough. And many samples actually saw this kind of problem, safety problem. But if you look at the stirring, like mixing effect, I would say EMS is more strong. If you look at the specific stirring power or energy, EMS is around 5 times higher than the gas. And this will create a global, like, mixing effect in the bath. There is no doubt. But of course, gas is only 3 to 4 or even 5 plugs. Still, the stirring is local. Then if you look at this operation, like maintenance, I would say ArcSave, basically the coil, there's no maintenance needed. Only there is some needed is auxiliary like equipment, like the frequency converter, water station, some minor maintenance work, like for the water station, maybe you need to change the filter for the industry water. That's minor. But the porous plug is very difficult to do the online maintenance work. And also, as Joachim said, this clogging of this porous plug makes the lifetime of the plug shorter than the pumping of the furnace. So this is a problem also. If you look at the running cost, I would say, depending on this application, this installation, where it's located. But if you look at Europe, North America, EMS running cost is something like 20 to 40% lower than the gas stirring. In basically, of course, this ArcSave is more like easy to operate, less maintenance and reliable operation, and compared with gas. That's why in our all reference like installation, 4 of them had been used as stirring before they changed to EMS. This is a good sample. Why I would say EMS. Thank you.
Thank you, Lidong. Joachim, the electrical energy saving that you mentioned in the results slides, does that include the energy that the ArcSave itself uses? And how much electrical energy does the ArcSave actually use?
The energy saving we have, then we are normally deducting the energy uses of the coil. So we are talking about the net energy, 3 to 5%. Regarding the energy consumption of the coil itself, we are talking about a number of 2 to 3 kilowatt hour per ton.
Okay.
That's my answer.
Another question for you, Joachim. Coming from medium voltage, low voltage motors and drives and power systems background applied to steel mill and large industries, could you please tell us in terms of MW, not sure what that means, what are the typical sizes of these great stirrers? I noticed that there is an ABB ACS converter. What is the typical model?
Very good question, and I like the word great stirrers. But if you look at the drive as such, we are choosing what we are called a multi-drive, an ACS 880. And normally this stirrer has an active power of around 600 kilowatts, also 0.6 megawatts. I think that explains shortly. I can give you a longer answer later on, but it's a short answer of the converter we are using.
Thank you. Joachim, if a customer wants to finance this kind of project themselves, is the simple payback return on investment around 1.5 years, just to clarify?
Hello. Yes, that's correct. As Anders said, we are talking about return of investment, of course, depending on the furnace volume and annual production produced. We are talking about 1 to 1.5 years. This is what we have seen from our references. And that includes then not just only the stirrer, it also includes the revamping of the furnace. It's very important to know this. Thank you.
Okay, another one for you, Joachim. How much maintenance is required?
Yeah, if we look at the maintenance as such, for example, as I mentioned in the presentation, the stirrer coil itself is very maintenance free. But let's say that the most of the maintenance is concentrated on the pump station or the water skid. And that means, for example, that you need to clean strainers, maybe you need to clean the heat exchanger every second year and so forth. So typically that is the maintenance what we have. And then regarding the frequency converter, of course, ABB has 24/7 service on this frequency converter, but it's not very much maintenance. Thank you.
Thank you. Anders, what is the typical delivery time for an ArcSave?
We usually say 8 to 10 months FCA delivery time. The bigger coils takes a little bit longer time than the smaller ones. Thank you.
Anders. Okay, Joachim, I think, let's see, we have another question for you. How many days of downtime would we have to have for the arc furnace to install an ArcSave?
Yes, very good question. Typically, if we look at our reference base, we are saying around 5 to 7 days. Of course, this needs, you need to prepare before the installation. So if you prepare the electrical board, transformer, water skid, the piping routing, the cable routing and so forth. And then when you have your annual maintenance stop, you then install the cradle on the rocker platform and then install the stirrer. So typically we can say 5 to 7 days.
Thank you. Lidong, does ArcSave have any effect on carryover slag into the tapping ladle?
Yes. Joachim already mentioned something. Yeah. As we know that the carryover slag to the ladle is normally due to the vortex formation in the EBT area during testing. And of course, all the steel makers try to reduce this carryover slag to save the ferroalloy in the downstream ladle furnace operation. And with ArcSave, actually the movement will move away this vortex from the surface of the part. So the vortex cannot continuously to form to suck downwards the slag. And this is the principle how it's going. So of course we need a little bit of velocity to cut or prevent the vortex formation. And from the installation in US, actually we measure the slag thickness in the ladle after tapping when go to the ladle furnace position. And we found the carryover slag was reduced 40 to 50%. And this gave a good saving for the ferrosilicon calcium carbide in the ladle furnace position. And this accounts for around $0.7 per ton of saving for this project. Thank you.
Thank you, Lidong. Joachim, are there any safety considerations when it comes to an ArcSave installation in terms of the electromagnetic field that it generates for human health?
Also regarding the safety concerns of this, there is normally no safety concerns at all. Of course, if you have a pacemaker, you should not be around the furnace area. But also, when you are around the furnace area, we have also measured this on our installation, and there is no danger for the furnace operator.
Thank you. Lidong, does ArcSave have any effect on stabilizing the electrodes?
Yes, and actually this question also mentioned by Joachim in general, yeah. And ArcSave will stabilize the electrode, getting the electrode more stable. Actually, the principle is first, ArcSave, the main effect will be the temperature harmonization and also this convection flow. So if you have a convex flow, then the scrap melting is faster compared with without EMS ArcSave. And then in this way, the big scrap or bundles charged into the bucket, loading to the furnace, will have less effect for the scrap, like a stratification effect, and also less QE of the electrode. So that's two main reasons for the stabilized electrode. Also, from the installation, we found that the electrode current swing was reduced almost 50 to 60%. And this effect actually will give a good electrode saving in the project. For example, most installation will save around 6 to 8% of electrode. But some of our numbers, which shown by Joachim, 3 to 4%. But that is the customer also changed the electrode supplier, which is cheaper electrode, so that it's high consumption during our whole test. Basically, we can save around 6 to 8% of electrode, which is good. And also the stabilized electrode or arc also give a higher power input. So that's why the energy saving, the power on time saving mostly is higher than the energy saving, because you also have this effect, power on time, of course, high productivity. Thank you.
Thank you, Lidong. That's all we have time for. Thank you for all of your questions. If you would like to submit any more questions, you can. We will leave the chat window open for a little longer and allow you to do so, and we will contact you after the webinar with answers. Again, just to remind you, if you would like us to contact you directly about ArcSave as a product, then please write ArcSave in the chat window. And if you would like more information specifically about ArcSave as a service, then write service in the chat window. Thank you for your time. We hope that you found this webinar interesting. And that's all from us.